Hi everybody, welcome to Next Generation Science Standards 101. My name is Kirk Robbins. This is the first part of a series of online workshops, and this part one is called Getting to Know the NGSS. Like I said, my name is Kirk Robbins. I'm a science education consultant in the Puget Sound region in Washington State. On the screen you have the URL to my blog called Science for All. You also have my Twitter handle if you're interested in following me and getting some resources on science education. This workshop is designed for K-12 teachers. It is intended for teachers in Washington State, but could really be useful for teachers in any state that have adopted the next generation science standards. This workshop is sponsored by Washington State Laser, and more specifically funded through the South Sound Laser Alliance. We also want to thank the regional science coordinators. Many of the slides that are in this workshop are from the regional science coordinators and from lots of different teachers and leaders in Washington State and around the country. If you are a teacher and you work in one of the districts currently on the screen, Bethel, Clover Park, Federal Way, Franklin Pierce, Puyallup, Tacoma, Steilacoom, Sumner, or White River, we would ask that you please take the survey before you proceed and engage in this online workshop. If you've already taken a survey, then please don't worry about it. There are a few things you'll want to do to get ready for this workshop. The first is you'll want to find somebody to watch this with. It's really designed to be engaged with at least with partners or small groups and not necessarily by individuals. But if you are by yourself, I'm sure you'll figure out a way to make it work. Please do engage with the tasks. If we ask you to watch a video on a different site, please do that. If we ask you to take some time and jot down some questions, please do that. It'll make it much more meaningful, the learning. Please, you might want to pre-download some of the documents. I will cue you when we're using different documents, but you might want to download those. There is a handbook. There's a screenshot right now of the handbook. You might want to have a hard copy of that if you like to actually write on something with a pen or pencil, or you can download that and have that to just type into. You'll probably want to set aside about an hour for this. It should take about an hour. The video will not be an hour, but with everything that we'll ask you to do, it should take about an hour. And having said that, please be prepared to pause the video and stop and to engage in some other tasks from time to time. The agenda for this session is as follows. We're going to start by thinking a little bit about where did the next generation science standards come from? What's the story behind them? Then we'll shift to thinking about why do we even have these? Why was it necessary to have new national science standards? We'll think a little bit about how the next generation science standards compare to our 2009 Washington State science standards. We'll look a little bit at the timeline and think about how we might start to slowly implement the next generation science standards. And we'll think, so what do we need to know right now? For someone who's just starting to learn a little bit about the next generation science standards, what do I need to know about how they're set up and how they're built? So this is the first spot in this session where we're going to pause and give you a little bit of time to think. If you haven't had a chance to download the handbook, you'll want to do that now. And then you'll want to turn to page 2, and you'll notice that there on page 2, there's a 2-column sheet. It says before video and after video. So you're going to be looking at the before video column, and I want you to just jot down what are some things you already know about the next generation science standards, and then what are some questions you have? What are some things that you want to know? So pause this video and take a couple minutes to jot down some things on page 2 in your handbook. So you've had a chance to jot down some initial ideas about what you know about the next generation science standards, a couple questions that you might have. Now we're going to have you watch an introduction to the next generation science standards video clip that was put together by Achieve. You'll find the link to this off to the right of where you're watching this video. It should say Intro to NGSS video clip. So you'll take a couple minutes to watch that and then come back to this video. After watching the video, we'd like you to go back to your handbook on page 2, and now on the right-hand side of that page, just jot down a couple things that you've learned from the video. So after watching that video, what are some things that you now know about the next generation science standards? And I'm betting that there might be a couple more questions that you have after watching that video. So take a couple minutes to fill in the right side of that sheet. We're going to take a couple minutes to debrief the NGSS video clip that you just watched. There are a few key points that I think are really important to make sure that are clear for all of us. One of those points is that I think it's Roger Bybee in the video clip who is talking about standards have the power to influence educational systems. So in other words, the next generation science standards aren't just things that we're going to plug in to our existing system, but that they might influence and help to change some things about educational systems in Washington state and across the country in states that adopt these standards. Another key point, somebody in the video had mentioned that science is more than a bunch of facts. So this is a key idea in the next generation science standards, that science isn't just a body of knowledge, but it's about how we actually get to that knowledge, okay? We want to prepare students for career and college. This is important in the next generation science standards and also in the Common Core state standards. And this idea that standards will change instruction. I think sometimes as teachers we feel like we can just plug in new standards and make it work, but for the next generation science standards, as we look at how innovative and how different they are, we'll need to think about how might our instruction need to change to really prepare kids to master these new standards. And then a final thing, focusing on doing science. A key part of the next generation science standards, as you'll learn as we move forward, is we want kids to learn science as they're doing science. So we want them to really authentically engage in the practices that real scientists and engineers use as they're learning science content. Let's talk a little bit about the story of the next generation science standards. How did we get to the point where we have this new set of national science standards? We're going to start our story in the 1990s when our last national science standards were released. And we had the National Science Education Standards, and we had documents from Project 2061. And following the release of those documents, in science education research, we really learned so much about how students actually learn science. We learned about things that happen in classrooms that tend to help kids understand science, things that sometimes happen in science classrooms that don't help students learn science. So there really became this consensus of research and knowledge about how students learn science, and that wasn't necessarily reflected in the last set of National Science Education Standards. In July 2011, a document was released called the Framework for K-12 Science Education. I tend to refer to this as the cookbook, and I call it the cookbook because it really provides the directions, the recipes for creating the next generation science standards. The next generation science standards were released in 2013, and they are the performance expectations that are based on the cookbook, the framework. If you haven't had a chance to look at the framework at all, I'll make sure that a link to it is posted on the side of this video clip so that you can download it. It's a free document to download. And what I've been finding is the more that I dig into the next generation science standards, the more that I want to go back to the framework to revisit some really important things. So the framework, we will continue to talk about the framework and its impact on the next generation science standards in this session and also in upcoming sessions. Another part of the story is to think about, well, who wrote these next generation science standards? Sometimes in education, I'll hear us talk about they, all these things that they are doing to us. So I think it's really important for us to not think about they did this, but that we did this. Um, there were 26 partner states that collaborated on the writing of the next generation science standards. One thing to note, if you know the story behind the Common Core state standards, this is a smaller group um, than the group that participated in the creation of the Common Core state standards, but still a majority of states. There were also multiple key stakeholder groups who helped to facilitate and contribute to the next generation science standards. Achieve, the national academies, the National Research Council, the Council of State Science Supervisors, and the National Science Teachers Association. All of these groups help to provide feedback and help to drive the creation of the next generation science standards. And most of these groups continue to support the implementation of the next generation science standards and are generating lots of great resources and tools for teachers and schools and districts to use. And I'll be highlighting a few of those in future workshops. I think it's important for us to know the role that we've played in the next generation science standards. We had over 4,000 teachers provide feedback during the time that they were taking feedback on the next generation science standards. We also had 3 individuals from our state who were on the writing team. And in October 2013, Washington State adopted the next generation science standards. So what does that mean? Did that mean that in October 2013 that we were all supposed to stop teaching the Washington State science standards and move to the next gen? Well, that's what we'll be thinking about for the rest of this session and the other upcoming sessions. So what do we need to know about the next generation science standards, and how do we start to implement them K-12? So besides Washington State, what other states have adopted the next generation science standards? At the time of the recording of this is what the map looks like. You can see that all of the West Coast has adopted the next generation science standards. Once California came on board, that was really important because now publishing companies, I think, will take the next generation science standards seriously since California is on board. You can see this is really different than if you look at a map of states that have adopted the Common Core state standards. It was like an almost immediate 48 states adopting those, right? And you can see that there aren't a lot of orange states on the map. The states in blue are places where there's a process in place to look at adopting the next generation science standards. Another thing is, when you look at the orange states, the adopting states, is that even though geographically it doesn't look like a lot, there are several populous states here. So there are many students will be learning about the next generation science standards. Another reason that this map is important to think about is that Washington State really is one of the lead states. So in terms of thinking to ourselves, well, maybe we can just see what another state is doing. It's like, well, maybe, but there aren't a lot of other states that we have to partner with. So we are one of the states that will be the first to be putting together resources and tools for the next generation science standards. There are several next generation science standards myths or misconceptions that I've heard in my work with lots of different districts, so I wanted to just talk about a couple of them. One is that the NGSS are not Common Core science standards. The Common Core state standards were a completely different movement, different process, different folks than what went into the next generation science standards. Sometimes you'll hear people say, these next gen standards are basically the same as our Washington State standards. Well, they really aren't. There are several commonalities in the way that they're set up, and I'll talk about some of those, but in terms of the actual performance expectations, the next generation science standards are very innovative, very different from any standards we've had in Washington State before. Another myth is that no state has fully implemented these yet, so you shouldn't think that some other state in the country has this all figured out. I think any adopting state is still trying to figure out how to do this exactly. The standards themselves don't prescribe a certain instructional material or a certain way of teaching. This is not a federally mandated or funded effort. Um, the two key questions that we usually have as teachers are, so when can I get my new curriculum? Um, and there really are currently no materials that are aligned to the next generation science standards. That's as of the recording of this session right now. There are some things that are starting to emerge, and there are some publishers that will say that their materials are aligned, but I think we're going to have to wait still a little bit longer until that happens. And then the other question that we have as teachers is, so what does the assessment look like? We have some ideas of some sample assessments that we'll talk about in some upcoming sessions, but we really don't know what the large scale, high stakes assessment is going to look like yet. So let's take a look at the timeline. Usually as teachers, there are a couple of questions that we have when we learn about new standards. One question might be, so when are we supposed to start teaching these? And then another question might be, when are these going to be assessed on a high stakes assessment? So on this slide, I have some things for us to look at. So the top row is about the NGSS timeline. You can see that in 2013-14, the next gen science standards were adopted. And then you can see there's this blue arrow that just says transition, which isn't too helpful. And we'll actually come back and flesh some things out there. But it's really up to districts or possibly even individual schools to really decide what is the best transition plan for your context. You can see that as we keep going along that top row, there's this idea that hopefully by 2016-17, we might be fully implementing the next generation science standards. So we need to think, what does that mean to us? Just recently, and on the bottom left corner, you can see this is being recorded towards the end of May 2015. The latest word that we have from OSPI is that the 2017-18 school year would be the earliest that the NGSS would be assessed. So that language makes me think, at least, that there's a possibility that it could be later than that. So 2017-18 would be the earliest that NGSS would be assessed. So now let's take a look at the next row down, which is about assessment. And you'll notice that it shows the grade 5, grade 8, science, MSP, and the biology end of course, that students are taking that in this current school year that we're in, 2014-15. They would take those assessments next year in 2015-16 and also in 2016-17. And remember, those assessments aren't being changed to assess the next gen. Those are assessing our 2009 Washington State standards. So the transition gets a little tricky, right? We're trying to implement something new, but we're assessing our students on our outgoing sets of standards. A couple other things I want to draw your attention to. You'll notice in the text box at the bottom, it says that we just found out a couple months ago that Washington State is working with a group of other states to build an assessment system for the next generation science standards. And we also just found out that hopefully sometime the coming summer of 2015, that there might be some documents that will be helpful to us. Things like some test and item specs, maybe a framework for what the assessment might look like. So those are some things that are coming. So really the takeaway from this slide is, in terms of when do we need to start teaching this, the answer is it depends on your system and what the transition plan is. And in terms of the assessment, there will not be a high stakes assessment built for the next generation science standards until 2017-18 at the earliest. So next we're going to think a little bit about the guiding principles from the framework, from the cookbook. The framework is based on these guiding principles. The first one is that children are born investigators. We know this, right? The kids come to us in kindergarten or even pre-K, and they're very curious about the natural world. They want to figure things out. What we tend to notice is that by the time kids start to get to middle school and high school, they've maybe lost a little bit of this. So what can we do as teachers of science to help nurture this curiosity? The next guiding principle is to focus on core ideas and practices. So what that means is that there are a lot of science ideas, and a lot of learners tend to be overwhelmed by that. So how can we focus on fewer core ideas that will follow kids over time, K-12? What that means for us as teachers, that some of our favorite things, some of the topics that we like to teach, might not be there anymore. So we need to be prepared for that and think about why that might be good for kids, actually. The next guiding principle is that understanding develops over time. This is huge, right? So I know in Washington State we have several places where in K-5, kids are kind of experiencing random acts of science, and we know that that's not good. Science needs to have some coherency over K-12, and that we know that science ideas need to develop over time. There are things that kids can learn about forces in motion in primary grades and intermediate grades that can help them once they get to middle school and then to high school. The next guiding principle, science and engineering require both knowledge and practice. So what this is about is the fact that science isn't just a body of knowledge, but it's a way of figuring things out and solving problems. In the past, we've called that content and process. And to be honest, we've usually focused more on the content and marginalized the process. So what the next gen does is it says, hey, when kids are learning science content, the disciplinary core ideas, they need to be engaging in practices and also using the cross-cutting concepts. Next guiding principle is connecting to students' interests and experiences. So we need to get better at this, right? I talk with a lot of students and former K-12 students who talk about science feeling very disconnected from their real lives and the real world. And that shouldn't be that way, right? So we need to be better at connecting students with the science that they're learning in classrooms. And the last bullet, the last guiding principle, which should probably be the first, is promoting equity, right? So how do we make sure that science and engineering is for every student, every year, and that everybody's being invited to the science learning party? Because that really hasn't been what's happened in K-12 science education in the past. Science has kind of been for certain kids, and we know that that's not helping them out, that we have groups of students who are not provided access to some of the science and engineering that they need to be provided access to, and that it's starting to become, or has been for a while, a social justice issue. So how can we think of science and engineering education that way, that it's really an equity issue that everybody needs to know about? So after previewing the 6 guiding principles from the framework, I want to give you a little bit of think time. So either in the handbook, if you downloaded a copy to write a little bit paper pencil, or if you're using the Google form online, just go through each of those guiding principles and jot down a thought or a question or a shift that we might need to make in order to make those guiding principles really come to life. So take a couple minutes of think time. So for the last few slides of our workshop today, we're going to be looking at the architecture, or the 3 dimensions of the next generation science standards. In this session, we're not going to actually look at any performance expectations yet. We're just going to talk about the 3 dimensions. The writers of the next generation science standards were very thoughtful about their use of color. So the 3 dimensions are always color coded. The blue always represents the science and engineering practices. The orange represents the disciplinary core ideas, and the green, the cross-cutting concepts. If you haven't had a chance to download the NGSS cheat sheet, you might want to do that now. The way that that's set up, it's to be printed 2-sided and then cut in half, so it makes kind of a bookmark style cheat sheet. And on one side, if you print it in color, it will have the 8 science and engineering practices in a blue box, the disciplinary core ideas in an orange rectangle, and the cross-cutting concepts in green. And then on the back, there are some key abbreviations and acronyms that will help in this session and also in the other sessions as we go forward. Earlier, we had talked about how the next generation science standards are not basically the same as the Washington State science standards from 2009, but there are some similarities and some comparisons that we can make that might help us as we transition. One of those comparisons is that the 8 science and engineering practices are similar-ish to taking our inquiry e-learn in Washington State, which is about doing science, and our application e-learn in Washington State, which is mostly about doing engineering, and kind of squishing some of those things together. It's not exactly the same language, it's not exactly the same, but similar ideas. Another similarity is that the cross-cutting concepts in green are very similar. A lot of the ideas are very similar to our systems e-learn in Washington State. So I think in Washington, we're really positioned to tackle some of those cross-cutting concepts perhaps sooner than in other states. And then lastly, the disciplinary core ideas in the next gen are set up actually in a very similar way to the domains of science e-learn in Washington State. So all the content doesn't necessarily match up in every grade band, but the way that it's organized by physical science, life science, earth space science, and then those sub-ideas, very similar way. These are the 8 science and engineering practices. It's the same 8 practices for a kindergartner as it is for a senior in high school who's taking AP chemistry or something. Obviously, they're going to look a little different in kindergarten versus high school, but it's the same 8 things that we want kids to be wrestling with. We will have a future session that will focus exclusively on the science and engineering practices, so I'm not expecting that we are mastering these by just showing this one slide, but I do want to give you a chance to think a little bit about these. There are really 2 key questions, I think, the first time that we see these. One question is, so which of these practices do I think my students might already be using a little bit? And then which of these practices might be new? Which ones might they not be using very often in my classroom? So I would ask you to pause the video for a couple minutes and with your partner or just by yourself, share some thinking. Which of these do you think your students are already using and which of these might be new to them? The cross-cutting concepts, the green on your cheat sheet. We will also have a full session where we dig into the cross-cutting concepts. So again, not expecting you to know everything about these, but just want to get them on your radar. So there are 7 of them. The idea behind the cross-cutting part is that each of these concepts applies to something in life science, earth space science, physical science. For elementary teachers, some of the cross-cutting concepts actually cut across content areas. So for example, patterns is something that's also a mathematical idea. Cause and effect, we often talk about in literacy or even social studies. So many of the cross-cutting concepts can apply outside of science even, which is very interesting, and we need to leverage that. So the 7 cross-cutting concepts are patterns, cause and effect, scale, proportion, and quantity, systems and systems models, energy and matter. And the reason I bolded energy and matter is that we tend to think of that as content, something that is a disciplinary core idea, which it is, but energy and matter flowing through physical systems, earth space systems, living systems. So there's just a really nice connection there for kids. Structure and function, and stability and change. So those are the cross-cutting concepts. The orange section on your cheat sheet is the disciplinary core ideas. And for a lot of us as science teachers, this is typically what we think about when we think about science instruction. We think about what we've called the content, which we're now calling the disciplinary core ideas. Okay? So a lot of times when we look at the next generation science standards, we tend to focus just on this part. And we need to know that about ourselves, that we're going to tend to focus on that. And we might marginalize things like the science and engineering practices, the blue, or the cross-cutting concepts, the green. Okay? So the way that the disciplinary core ideas are set up, we've got some ideas in physical science. One thing to notice is waves in physical science has really been elevated in the next generation science standards. So that's something we're going to have to think about K-12 is we may not have had as much instruction on waves as what next gen will be calling for. Life science, we have our 4 ideas there. Earth and space science. The next thing I want you to notice is that there's also engineering, technology, and applications of science. So engineering shows up as a disciplinary core idea, and it's also in the practices. We'll return to that in a future session on engineering to really see that engineering gets kind of a double dip in the next generation science standards, and that's a very good thing. So it's in the practices, but there's also content we want kids to know about engineering. So we've talked about the science and engineering practices, the disciplinary core ideas, the cross-cutting concepts. One of the big differences between the next generation science standards and any other set of science standards is the integration of those 3 dimensions. So in other words, in the cookbook, in that framework document, what it says is when you write your performance expectations, every performance expectation needs to have a science and engineering practice, a disciplinary core idea, and a cross-cutting concept. So they're not assessed individually, but they're assessed together. Okay, so on this slide, we have 3 different ways to think about that. You could think of that as like cogs working together. You could think of it like a Mobius strip where they're all connected. You could think of it like strands that make a rope. Whatever model works for you, you just need to know that when you start to look at the performance expectations, which we'll do that together in another session, that every performance expectation has a practice, a core idea, and a cross-cutting concept. So I want us to go back to a couple ideas that we talked about earlier. One is, so how do the 2009 Washington State Science Standards compare to the next generation science standards? And then also this idea about the 3-dimensional nature of the next generation science standards. So the next couple slides come from Dan Gallagher in Seattle Public Schools. So thank you, Dan, for making these slides. On this slide, we can see our 4 ELers from our old Washington State Science Standards. So we had systems, inquiry, application, and the domains of science. And the way that those standards are set up is that in systems, there might be a standard that's about identifying inputs and outputs to a system. So there'd be a specific performance expectation about that. We would have instruction on that, and we would assess it in some way. And on our high stakes assessment, there might be an item on that about inputs and outputs. In inquiry, there might be a performance expectation about writing conclusions. And we would teach kids how to write a conclusion, we would assess them on that, and there's probably an item on the 5th or 8th or the biology end of course test about writing a conclusion. Okay? So it's a one-to-one. We have discrete performance expectations, instruction, and assessment that match an idea in one of these ELers. So I want us to go back to a couple ideas that we talked about earlier. One is, so how do the 2009 Washington State Science Standards compare to the next generation science standards? And then also this idea about the 3-dimensional nature of the next generation science standards. So the next couple slides come from Dan Gallagher in Seattle Public Schools. So thank you, Dan, for making these slides. On this slide, we can see our 4 ELers from our old Washington State Science Standards. So we had systems, inquiry, application, and the domains of science. And the way that those standards are set up is that in systems, there might be a standard that's about identifying inputs and outputs to a system. So there'd be a specific performance expectation about that. We would have instruction on that, and we would assess it in some way. And on our high stakes assessment, there might be an item on that about inputs and outputs. In inquiry, there might be a performance expectation about writing conclusions. And we would teach kids how to write a conclusion, we would assess them on that, and there's probably an item on the 5th or 8th or the biology end of course test about writing a conclusion. Okay? So it's a one-to-one. We have discrete performance expectations, instruction, and assessment that match an idea in one of these ELers. So one of the big differences in the next generation science standards and how the performance expectations are set up is that we're no longer assessing these things in isolation, but we're integrating them. So what does that look like? It means that each performance expectation has a little bit. It has a science and engineering practice, it has a disciplinary core idea, and it has a cross-cutting concept. So we've never had instructional materials that do that. And we've never had an assessment system that knows how to measure that. So this is going to be a big shift, that these performance expectations, each performance expectation is connected to these 3 different dimensions in the next generation science standards. So that's going to have implications for instruction, for assessment, for curricula, for grading. So this is going to be a big shift. This isn't going to be something that we can just plug in new standards and say, all right, we'll carry on. Now we're doing the next generation science standards. So when people ask me what's one of the biggest differences between these standards and other previous standards, it really is this 3-dimensional nature to them. Now that we know a little bit more about the 3 dimensions in the next generation science standards, I want us to go back to that timeline slide that we looked at a few minutes ago. And I've added a few things to the top row. So you can see under 2014-15, these are some recommendations from the state in terms of what we might want to do to implement. And really what they're saying is keep teaching the things that you've been teaching, but think about where you could have kids start to engage in some of the science and engineering practices, the stuff in blue on your cheat sheet, any of the cross-cutting concepts, the things in green, and then if there are any places where the disciplinary core ideas happen to match up with what you're doing, then that's just gravy, right? So really what most experts in the field are saying is start with the science and engineering practices, okay? And that's really what we're recommending as well. So in the next workshop that we'll do online, the whole session will be on the science and engineering practices. You can see as we go through the timeline, it's just basically ramping things up. So adding more science and engineering practices, adding more cross-cutting concepts, getting real intentional about the disciplinary core ideas and matching those up. Next year, starting to think about instructional materials a little bit, whether that's adopting something new, moving some things around, or adapting materials with our eye on a target of trying to fully implement the next gen in 16-17. So in this first session, we've really had a lot of content, a lot of things to think about. So if you would turn to page 5 in your handbook, there's a place for you to write a final reflection. So I'd like you to think about what is one thing that you learned from this session today that you're excited about, something that you're excited about doing or using in your classroom with students. What is one thing that you're worried about? And then what is one question that you still have, something that wasn't answered from this initial session? So take a few minutes to do that. Now that you've had some time to think about the next generation science standards, I have a question for you that I'd like you to respond to. I'm wondering, what are you most worried about, most concerned about regarding the next generation science standards? And these are your choices, and you'll be able to click right in the video. What the assessment will look like? Is that something you're worried about? What my new instructional materials might be? What other professional development will I have? How might my instruction have to change? Or something else? And if it's something else, please leave a few notes about what that something else you're worried about might be. Thank you. Thank you for participating in this online module of professional development, Next Generation Science Standards 101, getting to know the next generation science standards. My name is Kirk Robbins. Feel free to check out my blog, follow me on Twitter at my Twitter handle on the screen. Please stick around and watch the next slide because we'll talk about the next session. This is just a quick commercial for the next session in Next Generation Science Standards 101, which will be part 2, digging into the science and engineering practices. In that session, you will develop a much deeper understanding of those 8 practices, discover that they actually are authentic practices that real scientists and engineers use, and have some tools to start to have kids engage with the science and engineering practices. Thank you.